Hi, I'm Rafael. I'm a third-year PhD student at Cardiff University, and I'm going to give you a little overview of my PhD project on discovering drugs for degenerative diseases. So, I mainly focus on a group of diseases called lysosomal storage diseases. This is a group of around 70 inherited diseases, which are mostly neurodegenerative. This basically means that they are caused by the degeneration or the death of your brain cells. The age at onset, so the age at which these diseases start, varies, but they predominantly affect children. Now, the diseases are characterized by progressive motor and cognitive decline, which is a bit like what you see in Alzheimer's or Parkinson's patients, which is the progressive loss of function in terms of your movement and your brain. The neuronal loss, which, as I mentioned before, is the loss of brain cells. And the reason they're called lysosomal storage diseases is because these diseases store lipids or fats in lysosomes, which is a compartment in the cell, which I will explain later. And this leads to early death. So quickly, just to show you why we do this is a photo of my first BDFA family conference. The BDFA is the Batten Disease Family Association, a charity mainly set up to help support families suffering from these diseases, but they also fund some scientific research, like my PhD. As I mentioned earlier, these diseases are due to the lysosome not working properly. Here we have what we call a wild type cell, or an apparently healthy cell, and here we have an LSD cell, which is a lysosomal storage disease cell. So like I was saying, in these diseases, fats and materials accumulate in the lysosome. The lysosome is the recycling center of the cell. So it goes around and it takes up all the materials that we don't need, breaks them down so that we can reuse them. When it's not functioning properly, these materials accumulate in the lysosome so that you have more and bigger lysosomes when compared to healthy cells, which causes all kinds of cellular dysfunction. So the main aims of my PhD is to find out what is going wrong with these patient cells and to test groups of drugs on the patient cells. Another aim is to do a more targeted approach, so find drugs that specifically target what is going wrong to see if they may help this disease. So an example here of how we see what is going wrong in the cell is your control is your apparently healthy cells, which would be these, and then down here you have your MPC disease, which is another lysosomal storage disease cell. And we look at the lysosomes in green, and you can see how they have many more lysosomes than your control. We also look at cholesterol here in blue, and you can see there is more cholesterol. But we can apply these kinds of stains to many other compartments in the cell. For example, your mitochondria, your endoplasmic reticulum, and many other things which we have done, and so that we can then test drugs. In terms of the first goal, we've found several drugs that may be of benefit, but due to the time constraints today, I'm going to focus on talking about the more targeted approach. We found that many of these lysosomal storage diseases have lower lysosomal calcium. Calcium is an extremely important molecule in signaling, so the communication in cells. And as you can see in this graph, your wild type again is your control. And some of these lysosomal storage diseases have lower lysosomal calcium. So I'm going to focus today on these diseases, CLN7, CLN8, and CLN10, which have lower lysosomal calcium. In our lab, we found that different supplements of curcumin is the main component in turmeric. We found that different supplements of this curcumin may actually target the lysosomal calcium defect. So we thought, could these be of benefit to some of the diseases where lysosomal calcium is an issue? Here we have, again, looking at lysosomes, we have control cells and then different diseases here without treatment, and then with a 4-hour treatment and 24-hour treatment. You can see when you compare your control to your CLN8 and CLN7 diseases that you have more lysosomes here. But then when you treat with the supplement curcumin, it seems to improve the lysosome. It seems to decrease the lysosomal storage, which may indicate that it's improving lysosomal function. CLN10, on the other hand, appears to have less lysosomes than the control. Due to other work in our lab, we believe it's due to a pH defect, which affects the acidity of the lysosome. But we can see that after treating with this curcumin supplement, it actually improves and it brings back the lysosomes to a level which looks like the apparently healthy cells. So from these results and additional experiments we've done, we found that this curcumin supplement may be of benefit to these diseases as well as other diseases that have a decrease in lysosomal calcium. So the main conclusions from my PhD is that we found several drugs or drug therapies that may be of benefit to lysosomal storage diseases, and these will be developed further by other members of my lab as well as the pharmaceutical companies we work with. We also found that targeting drugs to a specific lysosomal calcium defect may be a potential treatment for the diseases that have this problem. And this will hopefully help the children affected and their families. I want to thank all the wonderful people that contributed towards this project. Thank you, and I welcome any questions.